Earth travels through a cosmic neighborhood filled with planets, moons, asteroids, and comets, ancient remnants from the birth of our solar system. Sometimes, one of these space rocks crosses paths with Earth, blazing through our atmosphere as a meteor or shooting star. If it survives the fiery descent and lands, it becomes a meteorite, a direct link between our world and the universe beyond. These visitors can be as small as pebbles or as large as mountains. For centuries, meteorites were seen as omens. Today, we study them as natural phenomena that reveal the building blocks of planets. Meteorites are messengers from the past, carrying clues about the origins of life and our solar system. When a meteorite strikes, it releases energy far beyond anything we experience on Earth. Traveling faster than a bullet, its impact unleashes an explosion that can reshape landscapes and alter climates. This is a force of nature so immense, it can change the course of life itself. Our atmosphere shields us from most small impacts, but larger ones have shaped Earth's history and will again. Scientists study these events not just out of curiosity, but to protect our planet from future threats. By understanding meteorites, we become planetary guardians, learning how to predict and perhaps prevent catastrophic collisions. Looking up at the night sky is more than stargazing. It's witnessing a dynamic, sometimes chaotic environment. The story of meteorites is one of survival, science, and our place in the cosmos. Each impact reminds us how connected we are to the universe. When a large meteorite strikes, it triggers a massive explosion, not chemical but physical, as its speed comes to a sudden halt. The energy released vaporizes the meteorite and the ground, creating a blinding flash seen for hundreds of kilometers. A shockwave blasts outward, flattening everything in its path, trees, buildings, and life, over vast distances. The air itself becomes a weapon, compressed and hurled outward with devastating force. The shockwave also travels through the ground, making solid rock ripple and heave, forming the beginnings of a crater. For those near the impact, the ground would feel like liquid, violently shaking and reshaping the landscape. Even far away, the shockwave shatters windows and causes damage, while the explosion's roar echoes around the globe. The immediate aftermath is chaos, energy unleashed on a scale almost beyond comprehension. This is the raw power of the cosmos, a reminder of the immense energies at play in our solar system. Each impact is a stark warning of nature's destructive potential. Understanding these forces is key to preparing for future encounters. After the blast, intense heat engulfs the impact zone, heating air and ground to thousands of degrees, hotter than the sun's surface. A thermal pulse radiates outward, igniting anything flammable in its path. Forests, grasslands, even buildings. Fires erupt instantly, spreading destruction far beyond the impact site. Vaporized rock and debris are hurled into the atmosphere, raining down as molten droplets that heat the air from above. This creates a global oven effect, sparking fires across continents and plunging the world into a smoky twilight. The result? A global firestorm, burning for weeks or months, destroying ecosystems and releasing massive amounts of smoke and toxic gases. This smoke blocks sunlight, setting the stage for a long, dark winter. The combination of thermal pulse and falling debris creates a hellish landscape, unbearable heat, choking smoke, and relentless fire. Surviving the initial blast is only the beginning. The fires mark the transition to long-term, global consequences. The world would be on fire and the air thick with ash. This fiery stage is a turning point, leading to climate changes that threaten life everywhere. The impact's heat is the bridge between instant destruction and the prolonged darkness to come. It's a reminder of how quickly our world can be transformed. The energy of a meteorite impact sends shockwaves through the ground, triggering earthquakes far stronger than any tectonic event. A mega-earthquake from a large impact could shake the entire planet, collapsing buildings and triggering landslides worldwide. Near the impact, the ground would ripple like water, permanently altering the landscape. Even on the far side of the globe, seismic waves would cause significant shaking and damage. If the impact hits an ocean, it displaces vast amounts of water, creating mega tsunamis, waves hundreds of meters high. These tsunamis race across oceans, scouring coastlines and flooding land far inland, wiping out cities and ecosystems. Even land impacts can trigger submarine landslides, generating additional tsunamis. The oceans become a weapon, spreading destruction to every corner of the globe. The shaking ground and raging seas show that an impact is a truly planetary event. Every major impact leaves a crater, a permanent scar on Earth's surface. The process is violent and fast. The meteorite slams into the ground, vaporizing itself and the rock, excavating a deep cavity. Shockwaves blast material outward, forming a blanket of debris around the crater. Gravity causes the crater's walls to collapse inward, sometimes creating a central peak or ring of mountains. In minutes, a flat plain becomes a vast, circular basin. Over time, erosion and tectonics can hide or erase craters, which is why Earth has fewer visible craters than the Moon or Mars. Scientists use advanced tools to find these hidden scars, which are crucial for understanding our planet's violent past. Studying craters reveals the size, speed, and energy of ancient impacts. The rocks inside contain unique minerals formed only by such extreme events. Craters are natural laboratories, letting us look back in time and understand the forces that shaped our world. Each crater tells a story of catastrophe and survival. The immediate destruction is terrifying, but the long-term effects can be even deadlier. Impact and firestorms throw dust and soot into the atmosphere, blocking sunlight and plunging Earth into an impact winter. Temperatures drop, plants die, and food chains collapse. Herbivores starve, carnivores follow. The cold and darkness threaten every ecosystem. Acid rain, formed from atmospheric chemicals, poisons soil and water, harming survivors. The ozone layer is damaged, letting in dangerous UV radiation after the dust clears. Life faces a hostile environment: darkness, cold, acid rain, and radiation. Recovery is slow and uncertain. The aftermath of an impact challenges life on every front. History gives us powerful examples of meteorite impacts. In 1908, the Tunguska event flattened 80 million trees in Siberia, an airburst that never even hit the ground. In 2013, a smaller asteroid exploded over Chelyabinsk, Russia, shattering windows and injuring over 1,500 people. These events show that even small objects can cause widespread damage. The most famous impact, Chicxulub, 66 million years ago, struck Mexico's Yucatan Peninsula. This 10-kilometer-wide asteroid triggered mass extinction, wiping out the dinosaurs and 75% of all species. The impact unleashed firestorms, tsunamis, and a global winter. These examples prove that impacts are a recurring threat, not just science fiction. Each event teaches us about the mechanics and consequences of impacts. They remind us of our planet's fragility and the power of the cosmos. Not all impacts are equal. Several factors determine their severity. Size matters most. Small meteorites burn up, but larger ones can devastate continents or cause mass extinctions. Speed is critical. Faster objects release exponentially more energy. Most asteroids hit at 1725 km per s, but comets can be even faster. Impact location is crucial. Ocean strikes create mega tsunamis, while city impacts are catastrophic for humans. The geology of the site can release climate-altering gases, worsening global effects. Composition and angle matter too. Dense iron meteorites penetrate deeper, while shallow angles can spread destruction over wider areas. Each impact's unique combination of size, speed, location, and composition shapes its outcome. Understanding these factors helps us assess future threats. Preparation depends on knowing what makes an impact truly catastrophic. Studying meteorite impacts isn't just fascinating, it's vital for our survival. Impacts have reshaped Earth and reset evolution, as the dinosaur extinction shows. By learning from past events, we see how vulnerable our civilization is. Major impacts are rare, but smaller ones are more frequent. It's not if, but when. That's why scientists worldwide scan the skies, tracking near-Earth objects with powerful telescopes. Early detection gives us time to prepare and develop strategies for planetary defense. This field is young but growing fast, uniting science and international cooperation. Understanding impacts reminds us of our place in the universe and our responsibility to protect our world. By watching the skies, we move from passive victims to active guardians of Earth. Our future depends on vigilance, science, and working together to keep our planet safe.